Aerospike. For those of you who don't know who Aerospike are, we make a database, a NoSQL database, very fast NoSQL database. If you follow Gartner, Gartner recently published a Magic Quadrant from the operational database management systems, and we were the only visionary database in the visionary category. So we're quite excited about that. We're excited to be here with eXelate. eXelate have been a great customer of ours for over the last 2 years. So as they've grown, we've grown as well. And in a moment, I'm going to introduce Jim Hackett, who's the VP with Tech Ops at eXelate. So he'll tell you about what they've done with us. I did want to give a plug to Internap. I don't know if anybody from Internap is here, but they actually sponsored the food. So they're partners with us.
Well, it's great food.
And I'm very grateful that it's sponsored the food. So I just wanted to give them a plug. If there was anyone from Internap, they'd come up and just say hello, just to give a synopsis of their company. I'm going to introduce Jim. This area of personalization is something that's hugely interesting right now. You're seeing a lot of articles and I think a lot of press coverage on it, a lot of analysts now talking about it because that's where they earn money, by coining a new phrase, or the context. They're talking about context processing now, which is the other big word. As a database company, you think, what's our interest in that? We kind of first started talking about this or thinking about this way back in the beginning of this year, January, February. And the reason why is our success at Aerospike has actually been centered around the advertising technology sector, the media sector. And it's just not been here in North America, but around the world. We have customers in Japan and China and India and Germany and the UK, as well as many customers here in North America. And we kind of saw the media sector as leading all the other vertical sectors. Normally you go to the banks and the investment banks first, because they're the ones who need this bleeding edge technology. But actually we were surprised, and not surprised, but 4 or 5 years ago, it was the advertising technology sector that set this whole thing going off about personalization. If somebody goes on your website, you want to know something about them so you can start to market to them. You want them to click on that ad, and that's where they earn money. It was interesting because really the second quarter of this year, we started seeing e-commerce companies come to us. And one of the largest e-commerce companies, the top 25 companies, actually came to us. They're a customer of ours now. What they decided to do, you won't be surprised, something very similar, familiar to people in this sector, is they've taken their whole product catalog, millions of SKUs, and put that into our database. And what they want to do, as customers come onto their website, they want to make sure that engagement with that customer or that prospect is richer and deeper. They want to offer them, make them offers, make them real-time coupon offers or one-time coupon offers. So something that we've already been seeing in the ad tech sector for 4 or 5 years, they're now starting to look at. And the reason why they're looking at it is because they're also scared of Amazon, right? They're also scared of all of us doing showrooming, because I know I do that. I go into Fry's or something, look at a TV and say, how much is it on Amazon, right? Can I get it cheaper online? We all do that. And so they want to stop that. They want to be able to know about us as we go into that store and seeing it, and suddenly get an alert if actually we are going on to Amazon. Then more recently, we started seeing the retail banks, the very sleepy retail banks who've been doing business the same way for a very long time. They suddenly got an app, but that's the biggest innovation they've made. They've actually, all of a sudden now they're doing the same thing. We're having conversations with them about, again, they want to know the context. They want to know why somebody's gone on their website at 4 a.m. in the morning and is now researching home loans or car loans. They want to understand the context, the reason why that individual has done that at 4 a.m. in the morning. So again, they're looking at this. How can they have a deeper engagement with that individual? And I was just telling Jim, I said I was quite surprised. Just last week, we were talking to an investment bank again, and we were talking to the wealth management division. So these are the guys that they court people like you, guys who've got millions of dollars, right? And they court people, but they wanted to look at the behavior of their financial advisors. So the financial advisors who advise clients and say, you should invest through this investment bank into this mutual fund. They wanted to look at their behavior to see if that behavior was going to say, you know what, they're going to leave that investment bank and take their clients with them. So that was the first time I'd sort of seen that. You know, this is just last week, and this is where we're real anger now that they're thinking we've got to really understand our consumers, our customers. So this whole space, I think we're in infancy, and the media sector, the ad tech sector in particular, has actually led the way. And to enable that, there have been companies like eXelate, and that's why you've seen companies like eXelate being so successful over the last few years. So with that, let me introduce Jim Hackett. Jim is, as I said, VP of Tech Ops at eXelate. He's been here at 2.5 years. So, you know, he's seen quite a bit of growth here. He's going to talk not just a bit about how eXelate has leveraged Aerospike, but the whole technology stack and put that in perspective. So Jim, thank you.
So I guess to get started, just to let you guys sort of know what my role is at eXelate, our technology team is broken into essentially 3 different areas. So we have an R&D team that creates all of our platforms that we can leverage for our technology. That's based in Israel. Our IT team, which manages all of our infrastructure, we use Internet as our managed service provider for our serving capacity. That's managed by our IT team. They're based in New York. And my team, which is the Tech Ops team, manages all of the integrations that we have with all of the publishers and data buyers that we have. So my team is sort of the glue between the pieces on the business side, the analytics side, and then R&D and also IT. So sort of just the elevator pitch on eXelate is we're a smart data company. So we are a big data company, but essentially what we try to do is whittle down all of the different components that are not necessarily targetable from an advertising perspective and put those into more easier forms for advertisers to leverage. We collect trillions of data points per month, and that is transformed into thousands of segments that we're pushing into different platforms. eXelate really looks at the advertising spectrum, starting at the bottom, looking at the consumer first to say that we want the content of the ads that the consumer is seeing that's more relevant to them, and then above that, working with publishers so that they can help monetize their own content. One of the things that could definitely get missed in the industry in general, from a targeting perspective, is that most websites that people visit are free. And the reason why a lot of those great content websites can exist and they can provide their services for free is because they have the ability to leverage their data or their assets via advertising. So the problem that we're trying to solve is how do we help advertising be more relevant to customers? So you're seeing ads that you care about or stuff that you're interested in. Again, how do we help publishers monetize their content, and how do we help advertisers reach the audience that actually wants their product? And this is essentially how we make our money. The technical challenges that I'm going to talk about today, because it's more specific to the Aerospike conversation, is browser-side cookies. Everything that we do is in real time. And anyone who works with cookies in the ad tech space understands that the larger that cookies get, the more complicated it becomes to store data browser-side. And for us, our revenue and our ability to monetize the segments and the information that we're getting from publishers is speed of the acquisition of the data. So we're getting it as fast as we possibly can from all those publishers, via whatever channels we can get it from, and then delivering it to the advertising platforms where that data can be used. This is becoming more and more important in the industry because the separation of time between when we acquire data versus when we push data changes the accuracy significantly, especially for things like age and gender, where we see a lot of people using shared screens, shared computers. So one of the huge pieces of our technology that we focus on is how do we bridge this gap? How do we close that up as tight as possible? So this is sort of a general overview of what the eXelate Data Cloud really is. What we do is we work with online publishers we give them a JavaScript tag or an iframe tag or an image pixel. They install it on their website, and they can pass to us any type of attributes that they have on the user. Generally, it's related to some CMS system where they have meta attributes that they're using for SEO or something similar, where they can pass those things on to us. Once we acquire that data, these are generally the areas that we look for data online and offline. We categorize it in our cloud, we segment it, and then we push it to different types of technologies where that data can be leveraged in the context of advertising. So for anybody who's involved in ad tech, terms like DSP, SSP, DMP should be very, very common to you. But essentially what these platforms do is they help publishers or advertisers get their message out on different websites in the visual space. So how we do segmentation. We're really a bit different, I think, than a lot of the partners in the ecosystem, especially on the data side. Everything that we do is in real time. Every piece of segmentation that we have is all done in real time. And this is why we're going to get into it in a second, why the speed of Aerospike, when we're doing database lookups, when we're doing database writes, this is incredibly important. So essentially what we do is the request comes in from the browser. This is coming from some online website. And this is before Aerospike. We read the browser cookie, which contained all of the user's historical information, all of their segments, publishers that they had seen, different sites that they had been to that we were tracking on that user. We then take the parameters that were being passed into our query string, and we normalize those and prepare them for a highly advanced rules engine. And essentially what we do is once we have those parameters that are going into those rules, is that it becomes a single aggregate segment for that user. So whenever we're getting to the point where we're going to sell the segments, any of the meta information, any of the information that a publisher doesn't want to go out will all be locked, and buyers don't see that. At the end of the day, the only thing that a buyer sees is a single digit, which is a segment associated to that user. eXelate does not do anything with PII or anything like that. Everything that we have is either based on a demographic segment, an interest segment, or an intent segment, which I'll get into in a couple minutes. After we pass the rules engine, we've built a real-time modeling implementation engine. The way that works is our analytics team can look at all of our data over a long period of time and come up with the rules of how a particular segment or a particular event is related to the rest of our data segments. What analytics can do is they can implement a model so that as we're getting all these real-time events, as we're getting all these real-time segments, that information will be pushed into the modeling engine, and the modeling engine will score that user in real time against the model. And if they fall into that model, it will create a new segment, a modeled segment, that can then be sold to an advertiser on the platform of their choosing. Finally, once that's done, it goes to the sales engine, and the way that works is all of our segments are, for any buyer to get them, the buyer needs to be subscribed to it. We're very protective of the data elements that we have for our publishers. We don't want there to be any data leakage or any type of data thievery. So whenever we create a segment, it needs to be specifically subscribed to each buyer. And then the last step is to write back to the browser. So the problems that we were seeing back then, the first thing, and this is the most important piece, is this whole thing that I just described, all the mathematics, all the segmentation, all the rules, all the whole flow, this must happen, including network latency, for our own SLA, in 250 milliseconds. So all of this is happening in a very fast way. When we were in the time where the cookie was directly in the browser, we didn't have any additional latencies or anything that we had to worry about as far as pulling in the data first. The problem with this method is that as our business grew, and we got more publishers and we got more buyers, the size of that cookie became incredibly large. And there's several problems associated to that. The larger the cookie size is, the longer it takes for the request to complete to the server. Some browsers treat cookies much differently than others. Firefox has more stringent rules than Internet Explorer, for example. So what you wind up seeing is that in certain browsers you could have some data loss because the browsers will start rejecting the cookie sizes. You can also see tag request failure because the browsers will start rejecting those things. And this is a problem that needs to be solved because our business is based on third-party tags being on these publisher sites, and if for any reason that publisher feels like we are having a negative impact to their site, they will take us down. So these are things that we really need to stay on top of. So the way that Aerospike fits into our stack is it basically replaced the browser cookie. Not completely, because we still need to store the cookie ID inside of the browser. But that key is what's used to unlock the Aerospike store of data. So the flow is exactly the same. The difference is that the first step in the path of creating a segment is to make a request to Aerospike in order to download the user object before completing the processing. And then the last step is writing everything back to Aerospike. What we've seen is that the Aerospike read and write latency generally, and by generally I mean well over 99.9% of the time, is less than a millisecond. So from the perspective of how we were looking at the difference between the browser-side cookie versus the Aerospike store, no increase in latency. And the reality is, since our cookies at that time, and this is going over 2 years ago, at that time, the cookie sizes were so large that it was actually negatively impacting the response time because the request time was taking longer. So it actually helped us out. Additionally, when we made that shift, our cookie size dropped by about 10x. So it was a huge amount of less packets that we needed to be sending over the web.
That's a question.
Yeah.
You said 10 milliseconds. Is that any caching involved, or is this just pure data?
Say again?
Any caching involved? You said 10 milliseconds. Any caching involved?
Over here, no, it's less than a millisecond.
Less than a millisecond?
No caching.
No caching?
No caching. Every single event that we get online is stored in real time. There's no way to cache it because generally speaking, the only thing that we can maybe cache is if somebody's refreshing the page. If somebody's clicking between different pages, we want to track each and every product that they're looking at or each and every event that they have. So there's no caching involved at all. I'm going to go into the size of our cluster in a bit, and we have the guy on my team who takes care of most of the stuff is Jackson, hopefully back there. I would say, probably once a month, we'll be doing some research into something, and what you wind up seeing, you have a wow moment. You're like, wow, like we're really pushing this much stuff at this speed with the amount of scale that we have. So we'll get into that in a second. And the third piece down here that was really interesting is when we had everything in the browser-side cookie store, if you wanted to make an update to your rules, or if you wanted to make some understanding of how your cookies were behaving, you necessarily needed to see the user again. Now that we have all of our user objects and data stored inside of Aerospike, we have access to those users even if we don't see them because we can score them against the offline database. This is a huge benefit to what we're doing. And it's allowed us to really grow our offline publisher relationship.
Well, sorry. I can think of architectures where you had an offline database, which you use for analytics, and you use the cookie for primary storage and real-time response. And so with that hybrid design, you wouldn't need only one. So you wouldn't need to see the customer to retrieve the cookie.
Well, you could, no, but I'm saying if
analytics on this.
so if we're going to go into it in a couple slides on how the offline process works, but essentially, if we know that a user has a particular segment and we're interacting with a buyer, we can sell that data server side. It used to be that we would need to wait in order to see that user again in order to get the data out to the buyer. So we could do the analytics and we could understand what the cookie IDs are and we could see everything, but actually getting the data out to those platforms became the challenge. So with this, when we're pushing everything back into the system, we're storing every single cookie ID that we're seeing. So for the next few slides, I'm just going to go through very top level how our architecture works. So again, going back to what I was saying before, our tag fires from the browser. The first step is we've implemented, or we work with a provider for a GSLD service. So based on your geolocality, you will go to one of 4 data centers. We have one in Amsterdam, New York, Texas, and California. Once you've hit that serving location, each serving location has a load balancer, redundant load balancers, and behind that load balancer is our platform, our proprietary platform, which is called eXelate. So this is what actually serves out all of our pixels. All of the eXelators are stateless. So in any kind of request where maybe on a page we're getting multiple hits at the same time, or we have some sort of a piggybacking strategy where we need to fire multiple texts for different types of reasons, users will be hitting any of these eXelators. A user is never going to go to the same eXelator. Makes testing a little bit difficult, but if we have any problem with an eXelator, we can just take it out, and the rest of the servers will be able to manage the load.
Randomly or they are predetermined?
The algorithm that we have on the load balancing is round robin. We've tried a few different methods before. Load balancers generally have their own bugs, so they have there are some probably better algorithms, such as least connections, where it's freeing things up. We've seen a lot of bugs with that in the past, and round robin works best for us. Beneath the eXelator layer, there's essentially a bus on the switch that talks to the Aerospike cluster. So whenever a request comes in to any of the eXelators, they have access to the Aerospike database and can pull that object in real time in order to start processing the request and segment the users.
Is this cloud-based or are you running on data centers?
We used internet for our managed service, so all 4 locations that we have are based on internet.
Is there no load balancing between the Aerospike cluster and the eXelator?
No.
Okay, it's like directed to.
All-
Are they aware of the instance that they're accessing in the cluster?
The way that we leverage the Aerospike APIs for PHP. Okay, so from an eXelator perspective, it only talks to the API.
And what is the technology stack for eXelator?
Oh, so it runs on CentOS 6, 64-bit, and we run, the server is Nginx. We leverage PHP FPM, and our code base is PHP. Okay, so I want to talk briefly about replication and what our replication schemes are. Just toying with the ordering of these slides. I'm going to go into what the definition of the namespaces are in a second, but I think that at this point it's good to go through the replication of what we're actually doing. So we broke out our user object store into 2 different areas, one for North America and one for Europe. So our North America replication policy is between New York, Texas, California, back to New York, and then back around. That replication structure is now managing in real time 1.1 billion objects. So we're getting the sub-millisecond on 1.1 billion individual lookups. And that's looking at 11 terabytes of utilized storage. Yeah. 14. 14 minutes. Everything is replicated. So it's at each site. Each site has 14 minutes. So any object that we create in New York is going to appear in California. And I'm going to go into a few reasons, some reasons why we have the replication scheme as aggressive as we are. There are some companies that I've talked to, I'll get into it in a second, but some companies will do replication once per day, where they'll do an import-export, they're doing once per week. Ours is all in real time, so it's as we're getting the objects, they're constantly being replicated.
Basically, 56 counts in North America. For four sites, 56 counts.
Europe does not have as many. Jackson, how many does Europe have?
America, North America.
There's 14 here, 14 here, 14 here. So it's 14. Okay, and that's looking up against an 11 terabyte database. So each of the objects contains quite a bit of information. Our European replication looks like this. We only have the one European site, but we still want to keep the European objects replicated. We replicate that to New York. The European user object space is currently 300 million objects, and a total of 1 terabyte of utilized storage. When I'm saying utilized storage here, I don't mean this is what we have available. I don't mean this is what is included, including the the overflow from replication and migrations, where you have a high watermark of 50%, say. This is literally what's on the box. That's the data that we're actually storing. That you can look up that we have against people. Our cookies.
You never run into the European privacy laws collecting all that data?
It's interesting. So Europe, each of the countries in Europe kind of has their own policies.
That gives everyone
I'm sorry?
That gives everyone
No, each country has their different policies. So if you're in Germany or if you're in the Netherlands, it's basically a hard no. And the reason for that is because in the Netherlands, for you to do any kind of tracking or have any third-party cookies, you necessarily must inform the user. So for a lot of publisher content sites, they have to make the decision that they are going to prevent people from using their site completely before they will allow any tracking to happen. The result is that a lot of those publishers have a huge difficulty in making money on their website, so it becomes more and more difficult. Germany has laws that aren't that strict, but Germany also has some things that are similar. The UK and France, it's a very different story. So Europe is, historically Europe tries to do things together and then they wind up all hating each other. So it depends on, depends on the day of the week, right? So,
How about the disaster recovery? Disaster recovery.
Yeah, so I'm going to go into a second on the replication, why we're doing it, but this is exactly why we do replication. In any of these cases, if we lose any of these nodes, we're fine. We have enough capacity at any combination of sites that if we lose a node completely, since everything is replicated, it's not a problem. The traffic based on our GSLD configuration will automatically be shifted to the next site. So there's no problems there at all. Even in the case that we had like a super catastrophic where we lose two nodes, we have a lot of things in place where we can disable a lot of configurations, essentially make our boxes static pixel servers instead of doing logic, which in order to make sure we're not impacting publisher websites. Okay, and then the final namespace that we have is the global lookup service. And I'll go into a second as well, but basically the global lookup service is storing publisher IDs when they want to give us offline files to match up their users against our users. It's very simple mapping. It's just their ID to our ID, so we can do future lookups. This is replicated globally, and essentially, again, the path is New York all the way back around to Amsterdam and back to New York. Currently, we're storing 1.1 billion objects, and it's 1.2 terabyte utilized storage. All of these namespaces are in constant action. Everything again that we do is in real time. So it's not as though we're doing any kind of we do batch processing for other aspects, but every single time that you see a tag that from an eXelate pixel is hitting the Aerospike server each and every time in order to so some of our methodologies. Obviously, with the amount of data that we have, we can't store everything in RAM, right? Obviously. So the way that we set everything up is our servers all have very large SSD drives where we're storing the data. Inside of the RAM, we're storing all of the keys that are associated to the users. We utilize the Aerospike TTL feature. That's actually set at, I didn't update this, it's 45 days on all objects. I've heard some strategies where, and even I used to work at X+1, and one of the strategies that they have in order to get around bots is they analyze their database, I believe, once per week in order to delete a lot of the bot cookies. We don't do anything. We don't do anything like that. We utilize the TTL feature. Whenever we see the user again, we reset the TTL back again to 45 days. It makes maintenance very, very easy, and it makes us being able to trend at what our general size is pretty easy. Because once we get to that 35th day, our general growth in unique objects, we basically have 99% of the internet covered. So we're not going to get targetable cookies, say. So we're not going to get that many new objects. The only thing that will change is the width of the objects. And that we need to stay on top of in order to understand if we need more servers or if we need more SSD space and those types of things. So this is the way that we actually store our data inside of the namespaces. Our user objects, and these are two separate namespaces, but they have the exact same function, just one for North America, one for Europe. is we store as the key the eXelate cookie ID. This is the only value that we store locally on the browser. And then we store all of the other information that we have on the user that we've collected on them. So it could be different platform IDs, it's all of the segments that they have, it's all of the publisher attribution. It's one of the more interesting parts of our business is each and every time that we sell a segment, we need to pay the publisher to give us that data. So we need to constantly track not only the segments that a user has, but all the publisher information associated to it, so that when billing time comes, we know how to properly pay out our publishers. And then our second namespace, this is what I just mentioned before, is some lookup ID. So it could be any ID that a publisher has. This could be a CRM ID, or it could be some household level ID or something similar that's hashed for us. We don't really know what it means, but that's linked up to some eXelate cookie ID or some set of eXelate cookie IDs. There's a lot of cases where offline partners will have a very single static ID, and if they can find that ID online, they'll pass it to us maybe over the course of a few different cookies. So that's why those IDs exist. And it's important because when we want to onboard data from a publisher based on their ID, I'm going to go into it in a second. We have a couple flowcharts, but basically what it's doing is it takes the lookup ID to find the eXelate ID, then it processes the rules and gets the segments back over here, so that we can sell it out to our platform partners. So this is sort of a quick breakdown of how that process works. So essentially, a publisher gives us a file that's a huge amount of these data elements, and this is their ID that's been stored in our system against our eXelate ID. And this is a set of parameters, and each of these parameters has some specific meaning that's relative to the segment, or it's relative to a set of information that we can use in order to create a segment. So we could say, if it's these two values, it really means this segment. Again, everything is anonymized. There's nothing that's direct to a person. It's just to a browser, to a browser. Our system normalizes that in order to pull in that information and sends this to our eXelator via a JSON post. So it takes in different types of values. PNG is saying what publisher it's related to, but essentially pushing all this data into our system. And what winds up happening is inside of Aerospike, when you want to do a lookup on that value, we've exposed our own web services to do that. So if we know that this publisher has this ID, this will tell us all the segments that are associated to that user. So going back a step here, again, we have all this information. This is the big data component, right? This is all of the huge amounts of different elements that we can get. All of that is getting converted to just these really simple digits. And that's based on our rules engine and how we're pushing stuff through. At the end of the day, from a platform perspective, they really don't want all the other information. They don't want to have to store all that. They don't want to worry about keywords. They don't want to do any of that kind of stuff. They just want these IDs, and because that's what they want to sell. They want those aggregate IDs because from an advertiser perspective, you don't want to target a person. You want to target a set of people. That's information that's useful to you.
You hold on to the other information that's lost inside the ID?
Not inside of the user object. So we have some of that information for analytics purposes, where we can analyze and we can use it for modeling, but we don't store any of it inside of our user object. So it's not necessarily available for rules, it's available for analysis. And so this is essentially what our breakdown looks like. This is what we just talked about. And then on the user object side, we wind up having an eXelate ID. That's what's mapped to this foreign ID, and inside of that will be all of the segments that were associated to that user, plus the elements that we just got from processing the offline data on behalf of that publisher. So one of the things that I would say probably the most interesting thing about working at eXelate is that we work with more platforms than anybody else. We work with more publishers than anybody else as well, but the platforms are interesting because they're utilizing a lot of the same technologies that we use. A lot of startup publishers that have good content, they're working with CMS systems. They're not working necessarily with things like managing billions of cookies. They're working with managing a few million users or something like that inside of their base, and probably not users who are logging in or you're tracking information against them in their system. It's really just a view content. for us, replication on all sites is the only way that you can maintain a proper SLA. There are times where there are networking hiccups, servers come down, load balancers fail. Even in the best case where you have fully redundant systems, it's one of those things where crap happens, right? And with our business, it's very important that we're constantly keeping up all of our segments. It's very important for us because that's how we make our money in order to get those segments out. But one of the things I think that I certainly take a lot of pride in working at eXelate is we work with a lot of mid-tier publishers, and we're really helping them maintain good content by allowing them to monetize their site. So if we have a time period, or maybe it could be several hours, where one of our data centers is down, either for maintenance or from some other problem, that would be all data that we would lose. So by being fully replicated, if we lose any site, we don't have any issue at all. And this is kind of a scenario, but essentially, let's say that we're having a cookie that's being tracked in our New York serving location over a few days. We're going to aggregate a lot of data against that user. If the New York data center goes down, our GSLB is going to shift everyone to Texas automatically. In that scenario, if we see another segment against that user that's being hitched up against one of our models or something like that, we'll be able to utilize that full user's history because everything's been replicated. We don't have any problem. And it's the same thing on the Aerospike replication side, is even if we lose an entire Aerospike cluster, what happens is the previous cluster will start queuing those things. So once we bring the cluster back up, it's going to start transferring everything back again. So it's a very safe way of looking at things. And again, without full replication, we wouldn't be able to keep up that SLA and maximize our potential. So with working with Aerospike and kind of working through sort of a lot of the issues around NoSQL solutions, we've had a lot of lessons that we've kind of, some we've learned the hard way, some we've learned the hard way like 3 times, unfortunately. But with each thing, we kind of learn new things, and we understand how to push the system better and make our system better. So number one is constantly monitoring objects. Preventing evictions is something that's extremely important, especially for our offline publishers, where we might get the data maybe 30 days later. So if we have any evictions, we would lose those users. The second thing here that's important is, since all of our stuff is happening in real time.
Could you define eviction?
Sure. An eviction is if you are essentially if you're out of space on an Aerospike. And there's special algorithms on the Aerospike side, but essentially what it's doing is it's removing the oldest objects. So expiration is the proper way. Eviction is the bad way. So the thing that's really interesting on our site, again, going back to everything is real time, is that we don't, as we're pushing data into the system, we don't have any we can't look at something and be very predictive about what some implementation is going to do. We're not scanning the entire table. We're not analyzing our data before we push it into Aerospike. So any kind of software release for us can have a huge impact on cluster sizing. So if our R&D team implements a new feature where they want to explode the user object for some reason, it could have an immediate impact on the overall size of our cluster, where we could be seeing evictions or other issues. So it's very important to constantly be watching this. We have a lot of automated monitoring and alerts in place, but a lot of it is you have to stay on top of it. You have to look at it a lot. 2, replication is hard. It's extremely hard. Even in the best cases, you run into networking problems, you run into switch problems, you run into bandwidth problems, and since we're pushing so many objects, pushing gigabytes and gigabytes and hundreds of gigabytes per day, if you have any type of networking issue, even if it's a very small packet loss, you can put yourself into a situation where you now have a huge backlog of replication that needs to go through. And again, from what I was saying before, since we want to take into account if a site goes down for any kind of disaster, if we're not replicating as fast as possible, we could be in a situation where that user could be sort of in limbo, you could say, where they'll have some level of data, maybe not complete, and they have some level of data from another site, maybe not complete, and then eventually somebody's going to win out. So somebody would lose data in that case. So it's very important to stay on top of this, and it's an extremely difficult problem to solve.
Do you also have consistency issues when you try to recover?
I'm sorry?
Do you also have consistency issues when you try to recover? Like if you have data loss and you try to...
Yeah, I mean, we see it from time to time. You can really only see it at the full-on object level. For top level, you could say. I think we have a replication factor of 2 at each of our sites for migration. So it does happen from time to time. Generally speaking, the replication between the sites on the Aerospike side, we haven't really had issues with that. We've had the front ends will have issues from time to time. The load balancer can have an issue with those things. So we see it with the amount of data that we're pushing. We're okay with there's going to be some level of inconsistency always. So we watch it, but we do see it from time to time. And the third thing is if anybody is sort of getting into NoSQL for the first time, specking is incredibly important. Before you want to implement the solution, you need to understand what does it mean to have more than one namespace. When we first started, we wanted to have multiple namespaces specifically because of replication, because we didn't want to replicate all of the US objects globally if we didn't have to. And you want to do that because it makes the maintenance easier, so you don't need to manage all those billions of objects. But we definitely learned lessons where when we first started we had more namespaces that we were replicating, and what happened was the disks that we had started running out of space, and we needed to start reconfiguring things on the fly, which was painful. It was in the early days when we figured it out pretty fast, but the reason why we only had kind of that major issue is because we sat there and really thought about how we wanted to build this out. That's kind of what I'm saying down here is, as you're thinking about namespaces, as you're thinking about your storage patterns, how you want to access your keys, how you want to store keys, these will greatly impact what the cost of your cluster is going to look like. You really need to think about that before you do any level of implementation. So, just like one quick takeaway, I spoke with a few people at a meetup a few months ago. There's kind of this thing where a lot of people believe that NoSQL is sort of the solution to all of life's problems, not just big data. It's not. It's part of the stack. So even in our case, we use Aerospike as our real-time lookup service. We wouldn't use it for analytics. We use Netezza for that. Netezza can do aggregates very, very well. It can do it very, very fast. It can do it for huge sets of data. That's what Netezza is built for. Aerospike is made for quick access of data when you know the key. That's what it's built for. And we also leverage MySQL for our own internal reporting tools for the aggregates that we've stored. So all of these technologies kind of have their own place. Definitely in the NoSQL space, we've had an amazing experience with Aerospike, not just on the software side, definitely on the server side. The engineers that we work with, and Jackson can speak a lot about that, have been great to work with, very knowledgeable about our systems, not just the Aerospike system, but about our system. So it's very important for them to understand what we're trying to do in order to be able to support us as best as we can. Okay. And with that, I think it'd be good to have a bunch of questions, maybe some back and forth, and we're always hiring. So right now we're looking for a sysadmin on the IT team, and I am looking for another product support engineer on my team. So thank you. Thanks everybody for coming in.
There must be questions, so come on.
Would you talk a bit about the journey at Aerospike? In other words, what other products were looked at and what determined that Aerospike was the right solution?
Yeah, I think a lot could probably speak to it a little bit better, but at the beginning, we knew what we needed to do, and for us, speed was the most important thing, and the size of our data structures needed to be stored in an SSD infrastructure. And Aerospike was sort of the standout in that. And it doesn't hurt that we are about 100 feet away from AppNexus, who was the first to implement the Aerospike software. We have a very good relationship with them. They had many good things to say about Citrus Leaf at the time. But I think a lot, if you want to...
We've been looking at a couple of other solutions. We've been testing, looking at Mongo, Couch, Cassandra. We definitely have very unique use case, and the things that we've been looking at. We wanted to see a solution where you have the same ratio of read and writes, high-performing reads and writes, because as you saw with what Jim was explaining, we always, in each transaction, we have to read and write. We definitely were looking for a large-scale solution, and we've been looking to see if there is a reference in our industry, because there's not a lot of industries that are getting to that scale. And AppNexus was one of the references that they were quite happy with the solution. And the replication was a big factor for us. So we've been the first client for the Aerospike replication feature. So it was a beta first. Was working, and then it was working well. But that was one of the things that we've been looking for to this solution like that, because we didn't want to build replication ourselves. We wanted to support replication as part of our overall architecture.
I didn't quite catch the bottom how you managed to get cookie size by a factor of 10.
So in the past, we were literally storing all of our segmentation information and publisher information inside of the browser side cookie. So that's all gone now. The only thing that we store inside of the browser is the key to look up into the Aerospike. So everything that we have is stored.
So you just store a key.
The only thing we store is the key.
Weren't you tempted to put a little bit of stuff in that cookie, like to handle expiration?
So
Because you have to do a crawl to do expiration or eviction. And do you, by the way, do you replicate that?
to do a crawl for replication and eviction of define what you mean by that. The object in Aerospike or the segments?
No, the object in Aerospike.
The object in Aerospike, we don't do any crawling on the database at all. We leverage the TTL feature. So as long as that object, once it hits that TTL period, it deletes itself. It moves itself.
We don't really have any for full database scan. We don't do that. We don't have any offline process where we do that. Always there will be a direct access to the specific object we want to engage with. It can come from an online transaction, so we do the lookup from the cookie, or from some of the offline processing that we have that always will access a single
So it
transaction.
can do the expiration. And does it replicate those expired TTLs across your cluster, or does it do
The TTL is an attribute of the object. So as long as the objects are all getting replicated, that TTL, whatever the time period is getting replicated as well.
Do you have any idea of what percentage of the universe doesn't permit third-party cookies, and what percentage of the universe erases their cookies every time they close their browser?
It's an interesting question. So the industry stats for a long time have been that the relative blocking of third-party cookies is around 15%. It's extremely difficult to understand, because since you can't track anything, everybody looks unique. So from a unique percentage, it always looks very high. One of the things that we have seen definitely in 2013 is that there is generally a fundamental shift of browsing behavior towards mobile, towards apps, towards tablets, towards these types of things. So even though we are seeing some additional capacity on the blocking side or things getting rejected, we're part of panels with the IAB and the NAI where we're looking at what the future is going to be like after the cookie, essentially, and what that means inside of those mobile spaces. So right now, I'd say for browsers, it's probably around 15% when it's there, and I think that in the coming 12, 18 months, I think things will change significantly on how those things are being sold.
Using high-end SSDs or using commodity SSDs for the scope?
We're using high-end, maybe Brent, do you know the specs on the SSDs that we're using?
They're at 480 gig at the moment. We have
Could you speak louder?
Brent, can you speak
Repeat the
up?
question.
Can you repeat the question, and I think somebody can hear your answer.
the what
No,
SSDs.
repeat the question first, please.
Okay. You mentioned the specs on the actual disk that we're using.
Yeah, no, like we're using high-end or commodity SSDs for the storage.
Commodity SSDs, any standard 480.
Yeah, we've been testing a couple of vendors, and actually when you need to get high performance, you really need to test and spec the actual SSDs.
Yeah,
So we've been testing a couple of them. The problem is not the actual performance that you get from the read, but how long they survive, basically. We had initially very good results with OCZ. It just went down, so I don't know if we'll see them anymore. Maybe Toshiba down the road, I don't know. But we settle on Intels. Intels are actually working well for us. But it is a commodity SSD for the most part. But it's really important to test and spec the hardware and choose the ones that are working well for your specific use case.
We have a lot of experience with SSDs at Aerospike. Ruben, do you just want to talk a bit about?
We actually open source a suite to test SSDs. Essentially we tell people to test them for 24 hours straight. The big issue isn't always the SSDs. It's usually actually the SSD controller combination. Many times you're running through a RAID controller, and the RAID controllers are not designed for SSDs. It's designed for spinning disks. So the throughput and latencies that an SSD can provide are often handicapped. So many times if you get a commercial server, which doesn't allow you to connect to the motherboard directly, which goes to a RAID card, you're in worse shape than cheap commodity servers, which allow you to just connect very simple SATA connections to the motherboard. Literally, cheaper is better in many cases. So on our website, we mention a few SSDs that we like and that we don't like based on our experience. But again, we open source a toolkit to let you test out your SSDs. And the toolkit emulates the reads and writes that are accessed from our database. So it's not just a vanilla test. And one interesting thing we discovered for anyone trying SSDs out for the first time, as opposed to a spinning disk, a hard drive, whatever performance you get after 5 minutes, you'll get 5 days later. Whatever the performance is. With SSDs, it's a different world because obviously there's firmware in hard drives also, but there's a much more complex firmware in SSDs. We've seen SSDs perform well on our benchmark test, our validation test, for a few hours and then degrade. You wouldn't expect that with a hard drive. So we literally say run it for at least 24 hours straight. So there's a lot that goes on. The big determinant of performance, latency and throughput, is going to be the SSD controller combination. And that's why we greatly recommend that anyone try that out. Again, we open source that, but again, it's accessing the SSDs similarly to the way our database does. So we do large block writes, copy on write activity, and obviously we do random reads for the queries.
How do you manage this case? There's RAID versus, and that type of redundancy, you can have multiple clusters. Where's your trade-off?
Do you want to respond to that?
Why do you come?
Can you please repeat the question?
So you could build yourself a highly reliable disk subsystem by using RAID or something like that, or you could ignore redundancy completely and have separate databases because you have a failover mechanism and a replication mechanism. There's going to be some trade-off in relation to size. How do you manage that?
So we keep the replication factor on a single side to the minimum. Okay, so on a side cluster, data will be only replicated once. And we allow ourselves to lose a node or maybe more, but it's still performing well on a single side. But the big redundancy gain for us is the replication between the sides. Because for any problem, assuming we're losing more than that, so the solution would be not just try and recover on a single side, they just failing over the entire traffic to a different site. So for us, the redundancy is based on the fact that we have multiple sites that are fully replicated. And this is good for our use case, not necessarily for any other use case.
So each site has multiple nodes and redundancy between the nodes.
Yes.
And then how is your disk then configured? Is it
I'll answer that. JBOD. We don't.
Okay.
So the redundancy is between nodes in the cluster, not between SSDs in a single node.
Okay. Thank you.
Sure.
You do something when retrieving your user object. I'm trying to understand your performance. You cache the user keys when you.
No, we store the user key in the browser key.
But you said something. You store something in memory, and I was trying to figure out before you retrieve the user object.
We store, so on the Aerospike side, in memory, all of the user keys are stored.
The object keys. It's not the user, it's the object
key. I'm sorry.
Okay. So with
NoSQL, different flavors, different providers, they will provide different layers of where they index and where they put the data and what level of caching they have. And in some solution you have control on that, other solution it's simply, it is what it is. With our implementing with Aerospike, we're not caching anything. Okay? The indexes of the objects are kept on memory, and the objects are always retrieved from the SSDs. Okay?
Yeah, so just I'll expand on that. Every query involves one SSD read only, exactly one SSD read. Everything else, the index and DRAM. So that's how you get 1 millisecond latency. You have to have 1 millisecond, less than 1 millisecond latency off your SSD. That gets back to what I said earlier. So
our requirement is to have that both for reads and writes.
Right.
And this is very important for our use case. And we didn't see this performance coming from other solutions, for example. So you might get very fast reads, but very slow writes, or the other way around from other solutions. And also important, your hit ratio. Okay. And this is for other solutions that might involve some cache. Because if you keep handling the same user, the same objects, and you keep a layer of cache because you assume that you keep meeting the same 20% of the overall audience, then a caching solution can work well for you. But in our case, it's much more than 20%. So if we're using a solution we're using cache just for 20% of the overall data, we're going to get very slow reads overall because the miss rate is going to be very high.
That's part of the whole internet concept, right? Anybody can be hitting any record at random. It's not as if you have someone who's constantly on your website doing logging in and doing something. They're getting hits from any cookie, anywhere, on any publisher. There'd be no reasonable way to cache. Again, there are many applications that lend themselves to caching, but a random hit from anybody, any random person, any one of us hitting a website right now is going to cause a hit to occur. An eXelate, we don't know about it, of course, but that'll happen, and so there's no way they can cache that.
You mentioned about using Netezza for analytics. So are you using Netezza only for collaborative or clustering or?
I'm sorry, can you repeat? I can't.
You mentioned you are using Netezza for analytics.
Yes.
So are you using it only for collaborative or clustering algorithms, or what kind of regression models you are using it for?
We use, our analytics team uses Netezza in order to understand our data around events or around other segments. And the output, or the knowledge that's gained from Netezza based on that is a model implementation that will go into the system.
But you are saying you don't store. So let's say I am on the site right now, I am browsing it, and tomorrow I am again there. You won't know it's the same user, so how are you differentiating the user experience?
We differentiate on the users because of the object key, which is stored in the user cookie, in the browser cookie. So each and every hit that we get from a browser has a unique random ID associated to them that is consistent throughout all of their events.
But when you want to, let's say, recommend or use collection or classification, what are the algorithms you are using? You mentioned you are using Netezza, so I'm trying to understand where does Netezza come into picture?
So all of the events that we see from all of our publisher sites, all of those events are stored into Netezza. And the key on each of those events is the object key that we're storing inside of Aerospike. So on the analytics side, they have every single event that we get, literally every single event from every single place. And all of those things can be joined up against the object key, which is what we store inside of Netezza.
So if I have let's say six different browsers, let's say Chrome or IE and Mozilla,
to us, they are all unique people. They are all unique cookies. They are not joined up. Yes.
Thank you.
Yeah.
So you said that a small merchant would like to know whether someone was at Amazon pricing something. Does that mean that Amazon is dropping your cookies so that you have visibility on people's browsing behavior at Amazon?
I would love it if Amazon did that, but they don't.
Yeah, but there's no reason for them to do that.
Yeah.
So how does the merchant get visibility on someone's browsing behavior at Amazon?
On Amazon will have their own data assets that they'll essentially do this for their own network.
I see. So in other words, that's not the case.
It's not the case from
Okay,
Amazon.
got it. Sorry, that was a theoretical example of how
There
it would be nice.
There's actually one thing that popped into my head. I had this up here before.
Yeah.
This is kind of an
Is that real data?
Yes, that's what I wanted to mention. Yeah. So actually, so what we're doing on this screen is, from what I was mentioning before, whenever the eXelators are getting fired, there is some portion of users that we take the data and we store it into a separate area inside of one of the namespaces in Aerospike. What this is this interface is looking at that random sampling of users in Aerospike, and it's tracking against a GeoIP lookup to the IP address of the type of segments that we're seeing on users. But all this is actually in real time. This is actual calls that are being fired from eXelator into Aerospike, and this is the lookup against Aerospike of where those users are from. It's kind of
So I know people can't see this, right? The ones in the back of the room. And it says things like enjoys music, interested in finance. Male, age 18 to 24.
auto buyer.
So it's all demographic and...
Demographic interest type segments, yeah.
But to answer his question, the small merchandiser can also look at the next page. That often, if they're at your website, they can look at they can see what site you go to the next.
Yeah.
So they can see whether people are going to his site and then going to Amazon.
Yeah, 100%. But from a small merchant perspective, they want to make money on people that are targeting stuff on other sites as well, leveraging their data, because they can get paid on that impression if it's their data that's being utilized for that particular target.
Oh, so it's two different things. One is where they're going, and the other.
100%. So in Amazon's case, they want to hold on to their data. They don't want to lose it because it's important to them. From a small merchant perspective, it's essentially gravy to them, right? Because they're being able to capitalize on the fact that they have a good website with good information that they can push out that advertising on the target.
I mean, this might be a question for Hanish, but like, what does the cost of Aerospike scale with, like storage, scale with processing? Like,
It's based on storage, on production, so data in production, and it's unreplicated, so it's unique data in production. And if you want to talk deeper about pricing,
okay, and then you can replicate it however many times.
Yes, absolutely. And you can, whatever you have in staging or testing or development, we don't count that. Right? We don't care about how many nodes you deploy. Again, that's up to you. We actually want you to have it as the best configuration.
Right. So, I mean, like, for you guys, like, does that causes problems with, like, dealing with, like, a storage limit?
Actually, we really like this model. I'm trying not to convert some of the other vendors we're working with to a similar model.
Okay.
So we're talking to other database vendors that are pricing based on cores and all the methods out there. And we really like this model because this is very predictable. Okay, if I want to gain specific performance and I want to spread it on more clusters and I want to replicate it, I don't want to pay more.
Okay, so how? I mean, like, I'm having trouble understanding why I thought. My impression is it's actually not predictable because like you can't predict, like I can't predict what the traffic is next year.
It's not a job, it's the size of your database.
Right,
so
but my traffic, if I have more traffic, I need more storage.
only if you have more users, right?
Okay.
If we have more traffic on the same users, it's simply it's the same user base and maybe the objects are a little bigger, but overall it comes to a certain size.
So the amount of storage that you are using is not actually, like, it's increasing at a pace.
It is growing. We'll pay more over time, but we know that if it's growing, we potentially generate more revenue, and this is one factor that we can easily control. If we're not making money from more users, we'll cut some less deals and get less users and save on storage. If we're making money and we're growing, then we have the revenue to cover that.
Do you have some sort of rule of thumb of, like, what, let's say you need X amount, do you need some percentage spare storage? Like, you keep increasing this?
That's a very good point. I think one of the lessons that I personally learned in the very beginning is that when you do planning, you need to consider the free space when you have to plan how many nodes. So when we started, it was very early days for us and for Aerospike, so it wasn't that advanced. Now they have calculators that will allow you to do that. But you need to keep around 50% of free space on RAM and on disk for the system to perform to that level and to achieve the ability to use nodes and still performing. We didn't knew everything about that when we started, but over time we discovered that you need to keep that 50% to 60% mark in both RAM and storage. So now we have all the monitors in place to make sure we're adding more and more if we need. But this is something you need to take into the account. So the actual utilized space is about 25% of the total amount of SSD storage that you have in a cluster, because you replicate at least once in our case, and then you have to keep 50% free. So we pay for 4x of the SSD space in hardware than we actually store in data.
Good. Thanks. Any other questions?
Some great questions, actually. Thank you. I don't know if anybody from Internet is here at all. I'll just give them a final plug.
Anyway, thank you very much. I want to thank Jim particularly.